Astronomers have discovered a rare planet twice the size of Earth that may be entirely covered by an ocean. Adding to the excitement, this planet, known as TOI 733b, orbits a star slightly smaller than the Sun in a remarkably short period of just 4.9 days. That's puzzling because the orbital period of the planet implies that it lies too close to the star. This means that something intriguing is happening on the planet that is allowing it to harbor an ocean of water on its surface. The discovery of this exoplanet has solved another long-standing exoplanet mystery, the Radius Valley puzzle. So how did astronomers discover this distant planet? What clues hint at the possibility of water ocean on its surface? Finally, and most importantly, why is the discovery of this exoplanet so critical to astronomy? Since the initial detection of exoplanets in the 1990s, our exploration of the cosmos has been relentless. We have encountered an astonishing variety of exoplanets, ranging from rocky worlds similar in size to Earth to massive gas giants like hot Jupiters. These planets exhibit a wide range of radii, with terrestrial planets typically measuring half the size of Earth and gas giants reaching up to 10 times Earth's radius. However, there is a noticeable gap between these categories. Exoplanets with radii between 1.5 and 2 times that of Earth are surprisingly scarce, resulting in what is known as small planet Radius Valley. Scientists have put forth various theories to explain this scarcity. One possibility suggests that mini Neptunes, which are larger than super Earths but smaller than gas giants, gradually shrink over time to become terrestrial planets similar in size to Earth. However, the process by which this shrinking occurs remains a puzzle. This is where the discovery of TOI 733b becomes exceptionally valuable, as it offers a potential key to unraveling this mystery. TOI 733b is an exoplanet that lies around 245 light-years away from Earth, in the southern celestial hemisphere. It's orbiting TOI 733, a yellow star that contains almost 96% of the solar mass. The planet was first located in the data collected by TESS, the Transiting Exoplanet Survey Satellite, so the name TOI 733 means that it's the 733rd TESS object of interest. TESS uses the transit method to look for exoplanets. When a planet passes in front of its host star, it causes a small dip in the star's brightness. By analyzing these fluctuations in the starlight, the presence of a planet can be inferred. The majority of the exoplanets found to date have been confirmed with the transit method. The transit method can also reveal some of the planet's crucial physical parameters. For example, by looking at the period at which the dip in starlight is occurring, one can calculate the orbital period of the planet. TOI 733b has an orbital period of 4.9 days, which means that it orbits its star very close. At such proximity, the high-energy photons from the star can ionize the planetary atmosphere and eventually disperse it away. This phenomenon is known as photoevaporation, and it's one of the possible ways in which mini Neptunes can shrink. The radius of TOI 733b was inferred by looking at the amount of starlight blocked by the transiting exoplanet. It was measured around 1.99 Earth radii, which places it in the small planet Radius Valley. The next step was to calculate the mass of the planet. Astronomers use the HARPS spectrograph to do this. HARPS is a high-precision spectrograph installed on the ESO's 3.6-meter telescope in Chile. It measures the star's radial velocity to hunt for exoplanets, and here's how it's done. The gravitational interaction between a planet and its star causes the star to move in a small circle or an ellipse. This movement affects the star's light spectrum, which can be observed from a distance. For a star moving towards the observer, the spectrum appears slightly blue-shifted, while for a star moving away, the spectrum is red-shifted. The spectral analysis reveals the strength of the gravitational interaction between the two celestial objects, and indirectly, the planet's mass as well. The planetary mass of TOI 733b was locked at 5.72 Earth masses by performing the same measurements for the star. The data we have so far, including the planetary mass and radius, allow us to calculate the planet's density. The figures suggest a density of 3.98 grams per cubic centimeter, which is slightly higher than that of Mars and less than Earth's 5.51 grams per cubic centimeter. Now this is where things take an interesting turn. The discovery has set the stage for some fascinating possibilities about the planet's composition, based primarily on its density. One hypothesis suggests that the exoplanet could have initially had a hydrogen-helium atmosphere, similar to Neptune's. If this is the case, photoevaporation might have stripped away this primary atmosphere over time. This process, however, may have led to the reformation of a secondary atmosphere, primarily composed of heavier elements. Alternatively, and more likely, the planet qualifies as an ocean world. Even in this scenario, the exoplanet would have lost its original hydrogen and helium atmosphere due to photoevaporation. The twist lies in the possibility of a remnant atmosphere saturated with water vapor, which is much more resistant to photoevaporation. This scenario would mean the planet has likely retained a significant amount of its atmospheric mass, resulting in an ocean world. However, determining whether TOI 733b possesses a secondary atmosphere, or if it's an ocean planet, is still a significant challenge. A detailed analysis of the planet's atmosphere is required for a definitive answer. Currently, the most reliable method for such an analysis involves the comparison of starlight that has passed through the planet's atmosphere with its unfiltered counterpart. But TOI 733b isn't an ideal candidate for such a probing exercise, necessitating the wait for the next generation of telescopes to uncover the atmospheric secrets of TOI 733b. Exoplanets residing within the Radius Valley, like TOI 733b, could hold the keys to decoding the mysteries of this valley. This exoplanet in particular is an excellent subject for such studies. It represents a small, yet potentially vital piece of the exoplanet science puzzle. Consequently, future follow-up observations by high-precision instruments will certainly provide data worth close examination. Recently, astronomers discovered a weird galaxy that does not emit any light. It's the first detection of a dark galaxy in the universe. If you missed this episode, be sure to catch up on this exciting discovery.